This is section 3.2. We're going to be solving linear systems, but this time we're going to do it algebraically. We're not going to be graphing. Solving by graphing is kind of nice if we want just a general idea, basic picture, but if we're looking for a specific, precise answer, then you're going to want to solve algebraically. We have a couple different ways we solve algebraically. Homework 16 through 27. Again, if it says something different in your packet, make sure that you change it to 16 through 27. Remember, the file that I printed was old file. All right, solving by substitution. So here we have a system. A system means we have two equations. So the top equation is 3x minus 5y equals 27, and the bottom equation x equals negative 4y. Now if you notice, I have x is equal to this. What that means is that they're exactly the same. When it says equal, it means they're exactly the same. So I can take one and replace the other. So that's what I'm going to do. I'm going to take this and replace my x value, since it is the same as x, in my other equation. I'm going to substitute in that negative 4y minus 8. I'm going to replace my x value. So I still have my 3 right here, still have my 3, but instead of x, I'm going to write negative 4y subtract 8. Make sure you do put it in parentheses. Subtract 5y, because I still have the subtract 5y, I still have equals 27. From here, you are going to distribute the 3. So distribute the 3, you have negative 12y minus 24. I still have my minus 5y equals 27. Combine like terms, negative 17y, add the 24, equals 51, and divide by negative 16, or sorry, negative 17, and you get y equals negative 3. Typically, if I'm just solving an equation and I get x equals or y equals a number, you'd be done. But in this case, remember what we're looking for is a point where two lines cross. Now I have the y value. I have the y value. What I don't know is the x value. So to find the x value, you take your, let me clean this off a little bit. So I know my y value is negative 3. So I'm going to take my y value, and I'm going to put it into one of the original equations. I'm going to replace my y. I can either put it in the bottom one, or I can put it in the top one. It doesn't matter. You'll get the same answer. So if I put it into the bottom equation, negative 4 times negative 3 is 12. Subtract 8 gives you an x value of 4. Make sure you do write your answer as an ordered pair with the x value and the y value. All right, so let's do an example. We have x plus y equals 10, and we have y equals 4x. So since the bottom equation, it doesn't matter which equation, as long as I have one equation that has one of the variables by itself. So in the bottom equation, I have the y by itself, so I'm going to take whatever that equals and substitute it in. Since it equals y, I'm going to replace my y value. So the top equation, x, I'm going to replace the y with 4x is equal to 10. Solve. X plus 4x is 5x. Combine like terms. And 5 times x, opposite of times is divide, and you get an x value of 2. You're not done because you have to find the y value as well. So you're going to take your x value, and you're going to go back up here, and you're going to either replace it here or here. It doesn't matter. You'll get the same answer. I will probably put it in the bottom one just because it's easier. There's less work involved. So y is equal to 4, and my x value we found to be 2. So I get a y. 4 times 2 is 8. So final answer, x is 2, y is 8, and that is the point where those two lines cross. All right, let's do another example. So this time the top equation has y by itself. So I'm going to take my y and substitute it. So I still have the 2. Don't drop the 2. But instead of y, I'm going to put 5x minus 4. I still have the 6x, and I still have the 56. Don't forget to put this in parentheses. It does need to be in parentheses, and you do need to distribute. 2 times 5x is 10x. 2 times negative 4 is negative 8. Combine like terms. Add 8. 16 times x, opposite of times is divide, and you get x is equal to 4. Remember, you're not done. You need an x value and a y value. So I know what x is, so let's go back up here. Okay, let's see. I will probably put it into the top equation. Again, less work involved. So y equals 5x minus 4 equals 5x minus 4, but my x is 4. So y is equal to 5 times 4 minus 4. 5 times 4 is 20. Subtract 4, you get y equals 16. Remember to put your answer as an ordered pair with the x value and the y value. And that is the point where those two lines cross. Some of the equations, or some of the systems, do not have an equation where it's solved for one of the variables. In other words, both equations are in standard form. When both equations are in standard form, you're going to want to use a different method for solving. So let's take a look. Notice I have these two equations, and they're both in standard form. So standard form, we're going to use a process called linear combinations. Another name for that is elimination method. So every once in a while I'll slip and call it the elimination method. But these days they've changed the name. They call it linear combinations. So what we're going to do is we are going to add the x's, add the y's, and add the constants. Now, we have a specific goal here when we add the x's, add the y's, add the constants. What we need is for either the x's or the y's, when we add them together, for either the x's or the y's to eliminate. Okay, one has to cancel out, if you will. If I do that now, if I add the 5x and the 4x, I get 9x, which does not cancel out. Doesn't cancel out, so that's not going to work. If I add the y's, negative 3y subtract 6y gives me negative 9y. Again, that doesn't cancel out. So what I'm looking for, what I need in order for this process to work, is for the constants, not the constants, the coefficients to be opposite numbers. In other words, if I have a 5 up here, I need a negative 5 down here. Or if I have a 4 here, I need a negative 4 here. Well, there's no real nice way to make that work with the x's. So let's take a look at the y's. This is a negative 3 and this is a negative 6. If I multiply the top equation by negative 2, what's negative 2 times negative 3 gives me a positive 6. So if I have a positive 6 here, if I have a positive 6 here, a positive 6 and a negative 6, that will cancel out the y's. So how can I turn this into a positive 6? If I multiply by negative 2. The problem is I cannot just multiply this by negative 2. I have to multiply everything, everything by negative 2. So here we go. Where did we do this? I have no idea what this is. Okay, so I'm taking this, I'm multiplying it by negative 2. If I multiply the 5x by negative 2, I get negative 10x. If I multiply the negative 3y by negative 2, I get 6y. And if I multiply the 1 by negative 2, I get a negative 2. I don't have to do anything to the bottom of the equation, although sometimes I do. All right. Oh, I know what this is. This means multiply by negative 2. Huh. Okay. Now that these two are opposite numbers, one's positive, one's negative, I'm going to add the two equations together. So I'm going to add the x's. Negative 10x plus 4x gives you negative 6x. 6y minus 6y gives me 0y is equal to negative 12. Well, if I have 0y, I do not need to write 0y. So right now I have negative 6x is equal to negative 12. It's negative 6 times x. Opposite of times is divide. Make sure you divide by the negative 6, not positive 6, is equal to positive 2. Once I know one of the variables, I plug it in to the original equation. One of the original equation, doesn't matter which. I'd probably do the top equation just because the numbers are a little bit smaller, but it doesn't matter. 5 times my x value of 2, which comes from here, minus 3y, again I'm doing the top equation, is equal to 1. 10 minus 3y. You got to get the y by itself. Subtract 10. And divide by negative 3. This is negative. Make sure you divide by negative. And y is equal to 3. So I know my x, which is 2. I know my y, which is 3. Make sure you give me both as an ordered pair with the x coming first. And all of this is in your notes, and we did it already. All right. So what I am going to do now is take a look at example 3. We have 4x, we have minus 2x. If I add those together, neither one will cancel. I'm going to look at the y's. I have a positive 3y and a negative 3y. If I add those together, then yes, they will indeed cancel. So that's what I'm going to do. I don't actually need to multiply by anything. So I'm just going to add the two equations together right here. Since my y's will cancel without actually multiplying by a number. 4x plus a negative 2x gives me 2x. 3y plus a negative 3y is 0y, or nothing. And 37 plus a negative 47 gives me negative 10. Divide by 2. You get x equals negative 5. You're not done. You're going to take this negative 5 and you're going to replace your x value. Doesn't matter which equation. I'll probably do the top one because positives are easier to work with, easier than negatives. So I have 4 times a negative 5. 3y is equal to 37. Negative 20. I got to get the 20 to the other side. Opposite of negative is positive. Add 20. You get 3y is equal to 57. This is 3 times y. Opposite of times is divide. And you get y equal, what does it equal? Goes in 1, 19. So what was my x? My x was negative 5. And my y I get to be 19. Remember to write your answer as an ordered pair. I need the x value, I need the y value, and you need to put the x value first. Let's see. All right, let's take a look at example 5. I'm going to have you do example 4 on your own. And actually, I'm going to do example 5 and part 2. I like to make the videos no longer than about 15 minutes, and we're getting to the 15-minute mark. So I'm going to stop here for part 1 and pick up with example 5 and part 2.